only have Sundaresan and Sahana now. Okay. So this is the problem for the benefit of Sundaresan. You have solved it. Maybe Sundaresan, you can explain it. So we can see whether, since you have already solved it. So can you tell me how you did it and what are the steps? So this is in sequence and series. So we can see that, okay, the series goes like this: 21 to the power of 18 plus 20 into 21 to the power of 17 plus 20 square into 21 to the power of 16 and so on. So let me ask Sahana one question. Can you identify what type of series this is? Have you been taught AP, GP in class 10?
Yeah, so AP we have been taught, but not GP.
AP has been taught, but not GP. Okay, so this is a GP actually. So you can see that if the AP, you add a constant D, then you get the next term. You keep on adding a constant value. Likewise, you keep on multiplying by a certain value called R or ratio. You get the next terms. It's similar to AP. AP is addition, GP is multiplication. Okay.
Is it a
So
combination of both, sir?
this particular series is only geometric progression. Okay, there are series which are combinations of both. What we call them as arithmetico-geometric series. So those are also there as part of your syllabus. So we have done some problems on that also. But this particular problem is only on GP. Okay, so you can see that.
Okay, sir.
So can you identify what is the common ratio or here? R equal to
20 by 21, sir.
correct. Because you see, every term there are 20, there is no 20 here. You get multiplied by 20, then 20, another 20, so 20 square and so on. So, and similarly 21, is 21 power of 18 to the power of 18. Next it is 21 to the power of 17 and so on. So it gets divided by 21 for every term. So that means R is 20 divided by 21. Gets multiplied by 20 and gets divided by 21. Okay, so this is your series. So it is A, similar to AP. Here A is 21 to the power of 18. A is 21 to the power of 18. R is 20 by 21. Just like D, the equivalent of D is R here. Okay, so we have A and R. So then we can find out the sum to so many terms. Okay, sum. So here how many terms are there? Starting with 18. Okay, and going up to 0. So for as far as 21 powers are concerned, as far as 20's powers are concerned, it starts with 0. Because 20 power 0 is the first term. Next it becomes 20 power 1 and so on. Last one is 20 to the power of 18. So that means 0 to 18. So how many terms are there? Sahana, can you tell me how many terms are there?
So A plus N minus 1D.
A plus n minus 1 into D. That is the nth term. Okay. So here you see that this is nth term and that is for arithmetic progression. So here you can see, it starts with 18, 21 to the power of 18 and goes on up to 21 to the power of 0. So 18, 17, 16, 15, up to 0, how many terms will be there? You don't need a formula for that. You can just mentally think and tell me.
19 terms.
Yes, 0 to 18, including 0, 1 to 18, there are 18 numbers. As I said, here it includes 0 also, there are 19 terms. So for this series, your A is 21 to the power of 18, R is 20 by 21, N is 19. So you have to find out the term, sum to N terms. Just like in AP, what is the formula for Sn? So this Sahana may not know. It will come to you later. But Sundaresan, can you tell me what is the formula for Sn?
A of
So
1.
n by 2 is 2a.
That is for, yeah, that is correct. N by 2 into A plus Tn. So that is your formula for AP. Okay. For GP it is different. This is GP, no?
Okay.
Yeah. So GP, the formula is, tell
A
me.
of minus r to the power n divided by 1 minus r.
Right. A into, so depending on whether R is greater than 1 or less than 1, you'll have to write the formula. If it is greater than 1, you write it as R to the power of n minus 1 by R minus 1. If R is less than 1, you put it as 1 minus R to the power of n. Both are same by 1 minus R. Just because in this way the terms will be positive, because R is less than 1, so we want to put 1 minus R in the denominator. So if R is greater than 1, we put it this way. So in this case, since R is less than 1, right, 20 by 21 is less than 1, so we use this formula. So A into 1 minus R to the power of n by 1 minus R. So it is only a question of simple substitution. Okay. So you got the value of R, A and n. So can you substitute and solve this? So A is 21 to the power of 18 into 1 minus R to the power of n. R is 20 by 21 to the power of n. Let's put this bracket here. Divided by 1 minus R. Oh, and this n is 19. So it is a simplification of arithmetic expression. That's all that is. Okay. So you can try it. Try to simplify. So I want to put it as 21 to the power of 19 minus 20 to the power of 19 whole divided by 21 to the power of 19. That is your numerator. Right. 1 minus 20 to the power of 19 divided by 21 to the power of 19. So I can write like this, taking 21 to the power of 19 as common. And this is 1 minus 20 by 21. What is this? 1 by 21.
Power 19, 20 to the power 19.
Sorry, Sana, if you have simplified, what are you getting? Can you repeat?
21 to the power 19 minus 20 to the power 19.
21 to the power of 19 minus 20 to the power of 19. Let me see. Let me do one more step. 21 to the power of 18 into 21 to the power of 19 minus 20 to the power of 19 divided by 21 to the power of 19 into 21 divided by 1 by 21. And I cut this, it becomes very good. So you are right. 21 to the power of 18 get cancelled. You simply get 21 to the power of 19 minus 20 to the power of 19.
What is simplified?
So it is given as k into 21 to the power of 19 minus 20 to the power of 19. So what is the value of k? Therefore, k equal to
1.
Very good. K equal to 1. That's all. The option given? Yes. Option number 2. Okay. Okay. Let me do another problem now. This is what I said, number 4. So number 5. Oh, again, wrong value is copied. Okay. So if nth term of a series is given as 5 plus 8 plus 14 plus 23 up to n terms. Okay, and Sn is a1 plus a2. It's a little, series within a series, you can say. So that the nth term itself is a 5 plus 8 plus 14 is what type of series is this? 5 plus 3, then it is 8 plus 6, then 14 plus 23. So this itself goes like a arithmetico-geometric series, because it is not arithmetico-geometric. It is a the common difference is an arithmetic series. It's the type of series where common difference is in arithmetic series. Okay. So let's say an okay. So first of all, let us determine this value of an in terms of n. Okay. You solved it, right, Sundaresan?
Sir, no, sir.
You didn't do this problem?
I don't got final answer, sir.
Okay, okay. Let's do it now.
So is the series a nth term or it is a arithmetic series?
See, this is not an arithmetic series or geometric series. This is a series where the common difference itself is in arithmetic series. Okay, so you see the common difference is 5. Between the first two terms, the difference is 3. Between the next two terms, the difference is 6. Next two terms, the difference.
So the common difference is also not an arithmetic series.
Yes, common difference is in arithmetic series, no?
The common difference is not an arithmetic series. Like the difference of it is differing. Differing.
It is not constant, but it is in arithmetic series, right? The common difference here, you see, it is 3, right? Next it is 6.
Yeah.
Next is 9. It goes like that. So common difference is not constant. In AP, common difference will be constant. But here, the common difference, if you see, this is an arithmetic series. So that is this the type of series where the common difference is itself is an arithmetic series.
Okay.
Okay. So how do we find the sum of up to n terms of this series? Sundaresan, you should know, right?
Yes, sir.
So tell me how you did this, or how you
Sir,
proceeded.
the A, sir, A n equal to 5 plus n by 2,
Hmm.
2 into 3 plus n minus 1, 3, sir.
But how did you do? You tell the steps, no?
Sir, actually, I do for A40, sir. First,
Okay.
A40 வந்து 5 வந்து அப்படியே இருக்கு சார். 5 பிளஸ் அதுக்கப்புறம் இந்த டிஃபரன்ஸ் வந்து ஏபியில் இருக்கு சார்.
Okay.
ஸோ அந்த இடத்துல n வந்து 40 சார்.
Okay. எப்படி 40 எப்படி
அப்போ
வந்தது?
n minus 2
A40.
சார் 40th டேர்முக்கு n40 தானே.
அது A40 கேட்டிருக்காங்க. Okay. You are trying to find out A40. Okay. Okay.
A40.
Okay.
ஸோ n by 2 into 2a plus n minus 1d அந்த ஃபார்முலாவில் சப்ஸ்டிடியூட் பண்ணி.
Okay. So can you tell me the first step? What did you do first? So step by step you have to tell now.
Yes, sir.
Yeah, tell me.
Sir, first I wrote 4 terms, sir. A1 equal to 5, A2 equal to 5 plus 3, A3 equal to 5 plus 3 plus 6, A4 equal to 5 plus 3 plus 6 plus 9. And then I found that the differences are in AP, sir.
Okay.
So that for all terms, 5 is constant, sir.
Okay.
So that I applied to A40.
Okay. See, the way you have to do is, you see that A1 equal to 5, A2 equal to 5 plus 3, A3 equal to 5 plus 3 plus 6, right? A4 equal to and so on, right? Therefore, an will be what will that be? 5 plus how many terms?
N minus 1 terms.
Very good. See, you see, A2 you are adding 1 term. A3 you are adding 2 terms, 3 and 6. A4 you are adding 3 terms. So An you will be adding n minus 1 terms. And this formula we can apply. This is arithmetic series, right? So here this series is like An equal to 5 plus 3 plus 6 plus 9 up to n minus 1 terms. So what is the sum of this series? This you can solve, right? Sahana, you can solve this, I think, right? 3 plus 6 plus 9 up to n minus 1 terms.
Yeah, sir.
Yeah, solve it. What will this sum be? Tell me in terms of n. Let's do it. This one, take it as a separate problem here, okay? For which A is equal to 3, D is equal to 3, and n is equal to n minus 1. Okay. So let's not confuse. Not n equal to n minus 1. This is number of terms equal to n minus 1. So how will you calculate the sum using these 3 parameters? How will you calculate this sum of this series? So we can put Tn minus 1. So because n minus 1 terms are there. So Tn minus 1 will be A plus n minus 1 into D. Three plus 3n.
So it will be 3n minus 1 whole square.
3n minus 1 whole square. Very good. Let's go step by step. So here, since the nth term is going to be 3n, okay, so you can see that also. First term is 3, second term is 2 into 3, 3 into 3, and so on. So Tn, the last n minus 1th term will be 3n. Okay. N minus 1 is, sorry, this is n minus 2, this is, that's why it's coming wrong. Tn minus 1 is 3 plus n minus 2 into 3. So therefore, 3 plus 3n minus 6. So it is going to be 3n minus 3. So at each and every step you should do such simple checking. So here the T1 is 3 into n minus 1. So 3 into n minus 1. Wait. A equal to 3, D equal to 3, n minus 1 terms. So the n minus 1th term is, n minus 1th term is 3 into n minus 1. So the first term is going to be where n equal to 2. Then only it will be T2 minus 1. So you put n equal to 2, you get 3. So second term is 6 and so on. So it fits. So Tn minus 1 is 3 into n minus 1. So I think you have already solved it, right? So the sum of this series is going to be, actually you can do it in an easier way. It is 3 into 1 plus 2 plus 3 up to n minus 1. Therefore 3 into n minus 1 into n divided by 2. Okay. So you will get the same thing. Even if you apply that formula like n by 2 into T, A plus T n minus 1, you put like that, you will get the same result. Okay. So I can see that this is in a simple form where you can take out the 3 and then it becomes 1 plus 2 plus 3 up to n minus 1 terms. Okay, or up to that will be n minus 1. So that means it will be 3 into n minus 1 into n. So I am writing it the other way, n into n minus 1 divided by 2. So an is going to be 3n square minus 3n 5. So, but here an is the nth term here. Okay. So an is 5 plus 3n square minus 3n divided by 2. One moment. Three n square minus 3n plus 10 whole divided by 2. So this is your formula for an. So A40 you can immediately determine. So you did that right, Sundaresan? A40 you can calculate. What will be A40? 3 into 40 square minus 3 into 40 plus 10 whole divided by 2. And what will that be? Can you simplify this, somebody? I think A40 comes to 3 into 40.
So 425.
4,800 minus 360, 120 plus 10. Thousand. Okay. AN equal to, sorry, this is wrong. Okay. What we have done is not exactly AN, because but AN is a sum. Okay. What we have determined is only the nth term. Okay. So here this AN is just the nth term. Okay. But they are given AN, so because we use the same nomenclature, it got confused. We got confused. Okay. So here this is your nth term. Okay. So in this series that is given to us, up to 40 terms, right? So this 2345 will be the 40th term in this series. But what is given is AN or A40 is sum of this series up to 40 terms. What we have determined is only this 40th term. Okay, so how to find this sum? So that, because this is your Tn formula is this. (3n square minus 3n plus 10 by 2, right? So therefore, AN is sum to these terms. So we put it as AN is 3 into sigma n square minus 3 into sigma n plus 10 into n. Okay, so whole divided by 2. So now we'll have to put the formula for sigma n square, sigma n, in this. So that means 3 into n plus 1 into 2n plus 1 divided by 6. Let me take this 1 by 2 outside. So I'll take the 6 out. So you can simplify this. So if you simplify this, what you get is n by 2 into n square plus 9. So this is your AN. Okay. You can check it out. You can try to simplify and see. So if this is your AN, which is equal to, you can say n cube by 2 plus 9n by 2. Okay. So if this is your AN, Your Sn is one level above. Okay. So what does it say? Sn is sigma of An. Right? So that's what is given, right? Sn is equal to sigma of An up to n terms, A1 plus A2 up to n terms. So once you have determined An, you have to again do the summation for Sn. So that means this is sigma of n cube by 2 plus 9n by 2. Is this what you did, Sundaresan?
No, sir.
Okay, because once you came up to this, An is n cube by 2 plus 9n by 2. So you can put n equal to 40 and determine the value of A40. But Sn, what you have to do is, again, sigma of n cube by 2 plus sigma of 9n by 2. So next level, you have to apply the same formula. Okay, so that means, sigma n cube is n into n plus 1 by 2 whole square. Plus 9 sigma n is n into n plus 1 by 2. So these formulas you should know. Sigma n square, we saw that it is n into n plus 1 into 2n plus 1 by 2, 6. Similarly, sigma n cube is n into n plus 1 by 2 the whole square. Okay. So in this formula, now you apply n equal to 30, right? S30 you can calculate from this. Put n equal to 30 in this expression. So what you get is 110,205. Similarly, we already got the formula for An, so you put 40 in that. A40 you get 32,180. So you can check it out. So therefore, the required value is S30 minus A40, which is equal to 110,205 minus 32,180. So this comes to 78,025. Sundaresan, did you now complete it? Did you, whatever you missed it, is it clear to you now?
Yes, sir.
Okay. So in this type of series, it is just applying the same rule repeatedly a couple of times, because An, we have got the formula. Then Sn, again you put that, sigma of that. So you get it in terms of expression in n. Okay, so then you apply the formula for Sn. Okay. Can we move on to the next problem? Is it clear? Anybody had any doubt? Sahana, could you follow? I know it would have been a bit hard for you.
Yeah, sir.
Yeah. So this is basically applying the same concept, but repeatedly applying the same concept, because the Sn itself is an expression in terms of the function of n. So Tn itself is a function of n, then Sn becomes, we use that sigma n square, sigma n cube and all that. Okay. So problems in IIT, generally they are of this nature. So let's go to next problem. I think we solved now 3, 5, 6. So this sixth problem seems to be left out. Did you solve it, Sundaresan? 3, 8. I've only given one or two steps and I left it at that, I think, on that day. Problem number 6. Okay. So there are certain numbers 3, 8, 13 up to 373. This is an arithmetic series. The sum of numbers not divisible by 3. What is that? So this Sahana, I think you should be able to solve it. Sundaresan, I hope you solved it, right?
Yeah, sir.
Yeah. Do it, Sahana. Let's see. நீங்க எப்படி போட்டீங்க சுந்தரேசன்? போட்டிருக்கீங்க இல்லையா?
சார் போட்டேன் சார், ஆனா சால்வ் ஆகல சார்.
இதுவும் வரலையா? ஓகே. Okay, so please do it now. I'll tell you the first step. First step is 3, 8, 13 up to 373. So this sum we can determine. Okay, first of all find out the SN of this. Okay, and then you find out the sums divisible by 3. So you can see first number is divisible by 3. Next number is not divisible by 3. Next number is not divisible by 3. And next number is, because here it is getting added by 5. 3, 8, 13, 18.
So next 18 and then 33, sir.
Correct.
Then 40.
Okay. Right. So how many terms will be there in this? How many terms? Do a little bit of thinking and tell me how many terms will be there in this? How many terms will be there in this? Okay. Then it is very easy. 2 arithmetic series, summation, and you have to subtract the second from the first because we exclude the numbers divisible by 3, right? Because they are asking for sum of numbers not divisible by 3. So that means you take the total sum and divide by subtract the numbers divisible by 3. So tell me.
For first we can use the TN formula, sir.
Okay. Okay.
A plus n minus 1d equal to 373, sir. So then substitute the value of A and D, so we can find the answer. It will be 73, sir.
Correct. So what is the value of n?
75, sir.
75. Sahana, did you also get it? What is the value of n here? So we have to find out the value of n, right? So Tn equal to A plus n minus 1 into D. And A is 3. $74. 370 divided by 5 is 74. Okay. So this is a series with A equal to 3, D equal to 5, Tn equal to 373, n equal to 75. So you can simply put the sum of this series. Now let's find out how many terms are there in the other series, 3, 18, etc. So you can simply find out what will be the last number. Okay. So is 373 divisible by 3?
No, sir.
373 is not divisible by 3. So அதுக்கு முன்னால உள்ளது என்ன? 5, you have to subtract 5. 368. Is it divisible by 3? No. So what is before that? 363. Right?
It is divisible by 3, sir.
3 is divisible by 3. So here the last term is 363. Right? So numbers divisible by 3 are 3, 18, 33 up to 363. So same way you can calculate what will be the n for this. Okay, so you can even put it, divide them all by 6 and say 1, 6, sorry, divide by 3 and write 1, 6, 11 up to. So you can write it even like this, just for simplification. Okay. So in this case, your again A is 5, A is 1, A is 1, D is 5, and Tn is 121. That means your 121 equal to A plus n minus 1 into 5. So n minus 1 into 5 equal to 120, n minus 1 equal to 24, n equal to 25. So for this series, there are 25 terms. In this series, there are 75 terms. A equal to 3, D equal to 15, Tn equal to 363, n equal to 25. So this is the series of numbers divisible by 3. This is your all numbers. Okay. So find the sum of the first one, second one, and subtract. Let's call it as S1. What is S1?
$75 by 2.
Tell me, 75 by 2 into?
2 into 3 plus?
2 into 3. 2 into, first term enna? A enna?
A 3, sir.
3. Yeah. So you don't put 2 into 1 all, just 3. Okay. N by 2 into A plus Tn. What is 3n? 373. 75 by 2 into 3 plus 373. Right? N by 2 into A plus Tn. That's all. So n by 2, 75 by 2 into A 3 plus Tn, 373. That's all. Tell me what it comes to. And your S2 will be similarly 25 by 2 into A plus 363. Basically, you take n and then the average. The average is 3, the first term plus last term, then divided by 2. So n into average. So there are n numbers, and take the average of those numbers by calculating the first and last term divided by 2. So n into that. So that's the easy way of remembering your sum to n terms. So did you calculate S1 and S2? 75 by 2 into 376. 75 into 188. This is similarly 25 by 2 into 366. 25 into 183. $75 into 188. So you do it as 3/4 of 100, right? Into 3 by 4. Into 3 by 4 is 47 into 3, which is 141. So 14100. This is 25 into 183. You put it as 100 divided by 4. So 183 divided by 4 is 45. 7.75. Now you subtract. $9,525.
Sir, I also got the same answer, sir. But it is not in the option, sir.
9525. It's not in the options. Okay, ma, option 3.
Yes, sir. Oh, I think I wrongly noted it, sir. I solved it.
You got the same answer, 9525. It is one of the easiest problems you can say, right? So it is two arithmetic series. So that's all that is. Okay. Good. Sahana, did you follow this problem?
Yes, sir.
Okay. So the answer is 9,525, which is option 3.
I got the last 2 digits mistake. I missed somewhere in between.
No, I could not follow. Can you talk a bit louder?
Sir, I made a mistake in the output, like the last and final answer. I made a mistake in the addition something in between.
Oh, that's fine. So long as you understand the concept and the method involved here. Good. Good.
Yes, yeah.
Nice. Okay. So let's do one more problem, and that's all the time we will have today. So we have seen up to 3, but that is 4, 5, 6. Okay. This is fairly again similar to what we had done before, and I think you should be able to do it very easily. Okay. A series goes like 4, 11, 21, 34, etc. Find the value of S29 minus S9 whole divided by 60. So what is the first step? What type of series is this? So, Sundaresan, did you solve this?
Yes, sir.
You did it. Okay, good, good. So what type of series is this?
The differences are in AP, sir.
Good, good. Here the differences are in AP. Okay. So if the differences are in AP, then what method do we use? Sahana, we solved a similar problem. So you tell me what is the next step?
Sir, we need to take the sum of the difference, the differences.
Yeah, the differences are in AP. So that means what you do, P1 is 4, P2 is 11, P3 is 21, and so on. So this you write it as 4 plus 7. This you write it as 4 plus 7 plus 10, and so on. So what will be Tn? 4 plus 7 plus 10 plus 7 plus 10 plus 13 and so on. So the Tn here, since the first term is this, so only the remaining terms, so n minus 1. So what is Tn? You have to get the formula for Tn in terms of n by solving this series. Solve this series and tell me what are you getting? Seven plus 10 plus 13 up to n minus 1 terms. What will that be?
Sir, 3n plus 1, sir.
3n plus 1. No, is that the 4 plus this alone is you are getting 3n plus 1, or everything together Tn you are getting as?
Sir, no, sir. Tn is 3n plus 5.
Tn is 4, no? 4 plus this series. So what is the sum of this series is what I'm asking. So what did you get?
The sum of
3 plus 5.
Sundaresh, you were telling something. Complete it. What were you getting?
Sir, I am getting the 7 plus 10 plus 13. The n minus 1 terms equal to 3n plus 1, sir.
No. It cannot be that simple. Okay. And what did you get, Sahana?
So I got Tn plus 5.
No. See here for this Tn itself, okay. Tn is the first term is 3n plus 1, second term is 3n plus 2, etc. But now this is not what I'm asking is not Tn. I'm asking sum, right? Tn is 3n plus 1. That is correct for this series. T1 is, you can simply substitute and see, no? T1 is, okay, 3 into 1 plus 1. 3, no, it's not matching. 3 into n plus 4 it is, no? This series, you can see, no, 3 into 1 plus 4. Then 3 into 2 plus 4. 3 into 3 plus 4. So Tn is 3n plus 4. Not 3n plus 1, not 5. So let's do it again. I don't know why you missed this. So here A is 7, D is 3, right? So that means your Tn minus 1 so Tn equal to 7 plus n minus 1 into d. So this will come to 7 plus 3n minus 1, which is 3n plus 4. Same thing that I have put. But in this case, there are n minus 1 terms. You put n minus 1 equal to, you put n equal to,
Actually, the 3n minus 3, sir, before step.
7 plus 3n
Yeah.
7 plus 3n minus 3. So that is what is 3n plus 4. Okay. So Tn minus 1 will be 3 into n minus 1 plus 4, which is so this is your last term. So Sundaresan, I think you have calculated for n minus 1 terms. So which is correct? 3n plus 1 is what you got, right?
Yes, sir.
Good. So 3n plus 1 is the,
I have a doubt.
yeah, tell me.
Because of 7 minus 3 is equal to 4 nature. Then how can we take 3n minus 1 common? Sorry, n minus 1 common.
No, it's not clear. Your question is not clear, Sana. Can you repeat? Which step are you talking about?
So second step, like the last one.
In this Tn minus 1, is this where your doubt is?
No, sir, I got it.
See, but here what you have calculated is only the last term, not the sum. Okay. Again, you have to calculate the sum.
Yes.
This, so calculate that. Because here the first term is 7, difference is 3, and the last term is 3n plus 1. Okay. So this is your last term because here there are n minus 1 terms. So they given the value of n. No, they are not given any value of n. So we will determine the value of S29 and S9. Okay. So we have only calculated Tn minus 1, not Sn yet. Okay. So this is sum of n minus 1 term. So this sum you have to determine. Okay. So this sum is this is equal to again n by 2. Here n minus 1 terms. Okay. Into last term, the n minus 1th term minus first term. Sorry, plus. Okay. A plus Tn by 2 into n number of terms. Right. N minus 1 is the number of terms by 2 into first term is 7 and the last term is 3n plus 1. So this is coming to n minus 1 into 3n plus 8 whole divided by 8. What that is the value of this series. Okay, that is what I asked you. So now your Tn is 4 plus this. See, you please look at it carefully. This is only the Tn. Tn itself is like a sum because this is the difference. If the difference is in arithmetic series, your Tn itself will be like a arithmetic series. Okay, so that's what you have done. So what you have done is only calculating the Tn of this series. At this stage, you can verify whether you put the n equal to 1 in this and n equal to 2 and check whether it matches. So you can do a few checks. T1 equal to 4 plus n is, you put n equal to 1, this vanishes, so it's simply 4. T2 equal to 4 plus 1 into 3 into 2, 6 plus 8, 14 by 2 equal to 4 plus 7 equal to 11. Right? It's matching, right? So simply you put T3, 4 plus n minus 1 into more and r to 9 plus 8, 17. Is it correct? 21. So you substitute any value of n, it should match with that. Okay, so that is how we are determining the value of Tn in terms of n. So your Tn therefore is equal to 4 plus so this you have to simplify and get it like a simple function in n or a polynomial. Then only we can solve it, right? So this is going to be therefore 1 by 2 then 8 plus n minus 1 into 3n plus 8 multiply 3n square plus 8n minus 3n minus 8. So this 8 gets cancelled, and what you get is half into 3n square plus 5n. Half into 3n square plus 5n. So now this is your Tn. So if this is your Tn, Sn will be sigma of this. Half a level so into 3 sigma n square plus 5 sigma n. Now you put the formulas. Can do some more simplification and take out this 2 also. So that means it is going to become 1 by 4 into n plus 1 into 2n plus 1 plus 5n into n plus 1. You can keep like this. I am stopping at this because there is no one more level of summation. If there is going to be one more level of summation, you have to simplify this also to a polynomial form. But here, since we only need to know what terms do we need? They are asking only for S29 and S9, right? So we can simply substitute 29 and 9. There's no need for further simplification. So S29 will be 1 by 4 into 29 into 30 into 59 plus 5 into 29 into 30. So we can take this, as you can see, 29 and 30 are appearing common. So this is going to be 29 into 30 into 59 and 5. So add 64. So it comes like this. So 1 by 4 into 29 into 30 into 64. So you get like this, you can cut it off, make it 16. So it is simply 29 into 30 into 16. So this you can multiply easily. 16 into 29. One 44, 14, 16 into 2, 32. Pannendu baaki one, 1. Plus 29 equal to 13,920. Same way you do S9. So here again you have the 10 and 9 as constants. So you can put it as 10 and 9 you can take out. So 19 and 5, 24. So this becomes 54 into 10. Okay, so what is asked is S19 minus S9. 13,380, right? S19, 29 minus S9 whole divided by 60. So you can, it should go, I think, yes. 2 6 are 12, 13, again 2 6 are 12, 18 to 23. Okay, so here the answer is 223. Is given the option. Okay, Sundaresh and Sahana, both of you, did you follow this?
Yes, sir.
Yeah, sir.
Okay, so you can see that typically the problems are in this manner, slightly complicated series. So it's time up now. So let me stop here. So next week, I don't know. I think if complex algebra is completed for you, I can start on the complex algebra, working on some problems in that. Otherwise, we will again do there are, I think, still more problems. I think we can do some more problems in the new chapter, that matrices and determinants. So we can do that. I think now we have covered almost all the problems, right, Sundaresh? It's a series, sequence and series, or is that still pending?
Yes, sir. Actually, so the 9th and 11th I'm pending, sir.
2 more problems are pending. Okay. So we can do those problems. Meanwhile, you can try also. You should also try to solve it yourself. Okay. And so till your teacher completes complex algebra. So once your teacher completes complex algebra, then we will take up problems on complex algebra. Okay.
Sir, I'll try to complete it by myself, sir.
Very good, very good. That is the spirit. You should all try yourself. Sahana, you too. Now you know this, fundamentals,
Yeah, sir.
these concepts. So I'm going to
Yeah,
send
yeah.
this to you, and it has got the remaining problems that are pending. So you can try to solve them yourself. Okay.
Okay, sir.
Okay. So any other questions, feedback? Are you following the sessions?
Yeah, sir.
Okay. Okay. Fine.
Sir,
Tell me, Sundaresh.
the complex and numbers அதில் ஃபுல்லாகவே பார்க்கணுமா சார்?
ஆமாம், உங்களுக்கு காம்ப்ளெக்ஸ் முடிச்ச உடனே தான் நம்ம போட முடியும். பிகாஸ் ப்ராப்ளம்ஸ் வில் யூஸ்வலி தி ஐடி ப்ராப்ளம்ஸ் வில் யூஸ் ஆல் த கான்செப்ட்ஸ். ஸோ இட் வில் பி அட் த ஹையஸ்ட் லெவல். இப்படிதான் இருக்கும். அதனால அது ஃபுல்லாக முடிச்சதுக்கு அப்புறம் தான் நம்ம ஐடி ப்ராப்ளம்ஸ் எந்த ப்ராப்ளமே டச் பண்ண முடியும்.
இல்ல சார் இந்த சாட்டர்டே வந்து லீவா இருந்துச்சுன்னா நான் அத அந்த சாப்டர் ஃபுல்லா பாத்துறேன் சார். சின்ன சாப்டரா இருந்துச்சுன்னா ஃபுல்லா நானே பாத்துறேன் சார்.
Okay. Okay. Um, let's see next week if you can start on complex, no problem. If you can follow, that will be good. So we can do that if you are ready. um, Sahana, before coming to next class, if you are coming, please review that complex numbers, that chapter, and come. Okay, please read that.
Okay,
I keep
sir.
telling in every class, you know, for IIT it is not enough to do some problems that the teacher gives, you know, or just watch somebody doing the problem. You should read the book. Okay, look at the examples, and first of all do the problems in your book. After that, come to this, you know, class and do some you know, problems which are directly from IIT. So you should practice all that. Okay, so first step, read
Okay,
the book,
sir.
read the books, examples, try out some problems based on those, and then only it will be easy for you to do these problems. Okay.
Okay, sir.
Okay, thank you all. Sundaresh and Sahana will take